myself. Okay, what is about this presentation? Well, this is a work that we have been doing for several years. I think I started this work in ITF about 4 years ago, more or less. And what I was trying to describe is what is the real way to deploy today IPv6. When we somehow invented IPv6, we were thinking that IPv6 will be deployed before we run out of IPv4. So at that time, the idea was, let's go to dual stack as much as we can, because this way we don't break applications and older applications still will work. However, the market didn't react as we expected. And the result is that we all know, it has been said in the previous presentations, we ran out already of IPv4. The only region that has a few additional months to live with IPv4 is Africa, okay? But this is just for the next 6 months, maybe 9 months, not really much more than that. So if today you want to start deploying IPv6, you cannot anymore in dual stack. In fact, going with the model that I am presenting, I have worked with governments in different regions of the world where we have been able to save up to $300,000 million for the first 5 years because investing in a connectivity for all the public administration with IPv6 only. That don't means that they are not able to access IPv4 contents. That's the reason for this presentation, to show you how you can deploy IPv6 only, but still reach IPv4 only contents that still exist. Okay, so I guess is this one. So this document, which you are really, really lucky, because I don't know how many of you know about the process in ITF, but it's a long process because it's based on consensus. It means you need to resolve all the issues that the people in the community find in your document. And then finally, when you go to the last call and it's approved, it takes several weeks or months to go to what we call the RFC editor. The RFC editor is taking a final look to editorial changes or possible editorial changes. So this document was stuck in the RFC editor for about 4 months, and precisely last week we got the RFC number. So you are the first one to get a presentation of a real RFC out of this document. So what I am describing in this document, and of course the goal of this presentation is not to give you all the details because that will be impossible. It's a document of about 40 pages, very dense document, is to describe how broadband, cellular, and even enterprise networks can deploy what we call 464X-LAT or NAT64, okay? NAT64 is the basis for 464X-LAT, and it's one possible alternative, but you will discover across the presentation that this is not enough. NAT64 is not the solution. Just a warning about the rest of the presentation. Then I am trying to resolve in this document also questions like, do we need to use the NAT64, which in the case of NAT64 only is mandatory, but in the case of 464X-LAT is not mandatory. Okay, so what are the pros and cons of doing or not NAT64, which and without the NAT64? What are the possible deployment scenarios? And what other issues we need to consider? And again, this presentation is not trying to look into all the technical details, just to give you an overall picture so you have an easy way to go through the document. Oops, next, the other one. So this is the presentation that you will see if you try to find out the document, and you can see that the document was, I don't know if this is a pointer, yes. It's not easy to see here, but I think it was 26th of November, the publication date. So it's really, really lucky thing that it was just 1 week before this meeting. Oh, this is on the other way. Okay. So what I am looking to describe the different scenarios, I am looking to the situation that DNSSEC may be broken with the use of NAT64. So in the scenario that we are looking, are the hosts going to validate DNSSEC? Because that brings different consequences. Are the applications or the host using IPv4 literals or older libraries instead of dual stack libraries, let's say, or instead of using DNS? This is a very important question, because sometimes, even today, developers, even for simple things like websites, they use literal IPv4 addresses. This is broken. You should not do that. We keep telling this to the application developers, but they still do that. Okay, so this is a very big problem when you try to get IPv6 working in a network. And finally, of course, we will have situations where you have all devices, maybe the vendor don't exist anymore, that are IPv4 only. So going to just NAT64 will not work in those networks. So this is a key part of the classification of the scenarios. So as a result of these three main questions, I classify the possible scenarios in two major groups. One of them is scenarios that we know will work, and scenarios that will work under special conditions. For example, a closed network, a military network, a very secure network that has no connectivity to internet. They may work in those cases, but they are really, really very special. So they need to have different specific considerations. So the first group of scenarios is, let's try to use NAT64 and DNS64. Wow, I have real problems to read my own text here. So, let me see. Okay, so the first one is NAT64 with DNS64. And this is assuming that you have both of them in the ISP network. The second one is when you are using an external party to provide some of the services, like, for example, an external NAT64 or an external NAT64 and an external DNS64. Today, this is already happening. Well, and the fourth one is just an external DNS64. Today, this is already happening. There are companies over there that give these services to ISPs or to enterprises. So you don't really need to have these services in your network. Why this is important? Because a NAT64 box from a vendor may be expensive, okay? If you use open source, of course, it's free. You just need to have a big server, maybe a couple of servers if you want to have high availability. So in the case of most of your traffic being already IPv6, which is today very, very normal, because when you deploy IPv6 in even a residential network, at least 65 to 75 of the traffic typically becomes IPv6 on day one, so overnight, then you don't really need to have the NAT64 in your network. Maybe you can save a lot of money just contracting that in an external provider. And of course, that traffic will go lower and lower and lower. So you will get at the beginning, maybe 75% of IPv6 traffic and only 24, 25% of IPv4 traffic. And then in the following months, as more and more service providers and content providers have IPv6 available services, this number will go down, okay? So you really will not need forever the external services. So why you are going to pay for a new box if you can just contract that for a few months or maybe a couple of years? That's the reason for that. Now, the next scenario is, let's look now into, instead of just looking for NAT64, let's use 464XLAT. 464XLAT, I described this in the previous meeting, is basically having the NAT64 in the ISP network or in an external service provider, as I just mentioned, and then having a CLAT at your network, which typically will go into the CPE, okay? So this is resolving one big problem, is, well, actually three problems, is avoiding breaking DNSSEC, is allowing IPv4 only host of applications to still work, which is not possible in the previous scenario. And finally, is allowing also those applications that use literal IPv4 addresses, or that they don't use DNS, or they'll use older libraries to still work. So in this case, we have three possibilities. We have 464XLAT with DNS64. We have 464XLAT with DNS64, but the NAT64 in an external service provider. And we have 464XLAT with DNS64 also in the external service provider. And then we have a similar situation, but without using DNS64. Today, most of the hosts don't validate DNSSEC. But there is a study that shows that if you are getting DNSSEC validation, you will get 1.7% breach of the DNSSEC validation. If you want to avoid that 100%, you can do this with 464XLAT. This is not possible with just NAT64, but with 464XLAT, you can avoid that. And then we have obviously here two scenarios, having the NAT64 inside of your network or having it in an external service provider. Now, when I go to compare all these scenarios, which in total become 12 different possibilities, I am following a criteria to classify them. And the criteria is looking into how much they break DNSSEC, if they work with literals, if they work with older libraries or APIs, if they will work with hosts which are IPv4 only, hosts or services or applications. We have the three possibilities. What happens if the user is changing the DNS? We call this foreign DNS. Why? Because today many people change the DNS and use 8.8.8.8. So if we rely on that, it's not going to work. Okay, so we need to consider that. What happens with the optimization of the load of the DNS? Because this is very important for a service provider, maybe not that much for an enterprise, but in a service provider, it's a big problem, okay, or big networks in general. And what about the connection optimization? This is especially important in cellular networks, okay? So this is the final table where I have all these 12 possible scenarios, and I am scoring them as they are doing well, so it's a positive. They are doing bad, it's a negative, or a wild card when there are possible solutions even they are doing bad, okay? So the conclusion at the end is basically that if you really want to have all these problems solved, all the problems that I mentioned several times already, like the IPv4 literals, the IPv4 only host, or the all applications that don't use the dual stack resolvers, then the only possible scenario is using 464XLAT. So that means using a CLAT, okay? A CLAT is not a big issue because if you look into the open source code of CLAT, is a small text like this. It's basically 6 or 7 lines of code, okay? So this is not a problem. If you, in addition to that, want to avoid breaking DNS, of course, you don't want to use DNS64. And that's the advantage of 464XLAT, that can work even without DNS64. In general, all the scenarios are good in terms of DNS load optimization, but in the case of 464XLAT, it may provide an extra degree of optimization. So again, this is a positive thing for using 464XLAT. And finally, regarding the delay optimization, well, there is something that today is implemented in most of the operating systems, which we call happy evols. And happy evols that has for probably 6 or 7 years, I don't remember the exact date when that RFC was published, was updated about 2 years ago. And happy evols version 2 provides even a better in the connection establishment than the previous version. And this is also supported today in major operating systems, especially in operating systems in mobile devices, in smartphones, and obviously also in many browsers that sometimes the operating system itself is not doing that, but the browser is doing that itself. What are the issues to consider? I don't know how much time I have. I am losing track of time. I hope I am doing well. I think I have only five more slides. So quickly, what are the issues I am considering this document is what the ISP need to consider for the deployment and what decision points you need to take care of. Okay, so that's basically what the document is describing. So the first issue is DNSSEC. I mentioned already several times about DNSSEC, so I'm not going to insist here, but here you have a list of what the specific details in the document are described regarding the support of DNSSEC without breaking it. Then we have DNS64 and reverse mapping. Well, this is easy, just works. So nothing special to consider, but I wanted to make sure that everybody, when reading the document, has a clear picture on that. Now, what about the decision of using DNS64 or not while using 464XLAT? Well, the thing is that if you don't use DNS64, you are sure you don't break DNSSEC, but then you do a double translation. And that means that instead of moving from 1% of utilization of the CLAT, you will move to 25%, which is the sum of the utilization of the NAT64 with the CLAT. This is what today we see in real networks that already use 464XLAT. So this is real numbers, not just imagination. This is from real networks. Concretely, this data comes from T-Mobile in US, which have been using 464XLAT. In fact, one of the engineers of T-Mobile is the inventor of 464XLAT, okay? And we see the same numbers in other networks. So I am just giving an example. And of course, this is going to grow. It means that if today you have maximum 25% of utilization of double translation in the CLAT and the NAT64, this will go down, 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 as much more traffic is going to service providers deploying IPv6, okay? Now, there is an important point here is this impacting in the ISP? Actually not, because if you do double translation, it means you are doing a double translation in the CLAT, and the CLAT is the CPE, so it has zero impact on the ISP. And CLATs today are the same box that you do today NAT44 in IPv4, so they are already able to handle that additional load, not problem at all. Now, this is a more complex topic. What happens when the user is changing the DNS? It may happen because of different set of circumstances. One of them is exactly the user changing the DNS, so using a manual DNS configuration. But what happened with the new encryption or privacy mechanism for DNS, like the DNS over QUIC, over HTTPS, and all those, DOH, etc., etc. What happens? This has some impact, and the document is explaining what are the solutions or what are the impacts. Okay, so you are aware of that as well. Again, if you don't use the NAT64, you get rid of all those impacts. So it's one more reason to not use the NAT64. And what happens when you have what we call a split DNS or VPNs? It's the same. You connect to a VPN and you have two DNSs. You have the DNS of your actual network, but the DNS of your VPN. What is the impact there? It's practically almost the same in all the cases. Okay, so just the document is going through to describe that. Now, I am not sure how many here know about NAT64, but in the NAT64 deployment, there are two possibilities of using the IPv6 prefix. One of them, which is the most common one, is using a well-known prefix, okay? And the other one is using a network-specific prefix. So in the document, I am describing the difference between one and the other, and why you should use one or the other depending on your specific case. Again, talking about the impact of literals and IPv6, non-IPv6 compliant libraries, resolvers, IPv6 only hosted applications, considerations for the CLAT translation, which is also important if you are going to do a tender to buy CPEs, for example, that support the CLAT. You need to tell your vendors, your possible providers for the CPE, what you want to do, because depending on how you are going to deploy the addressing plan of the IPv6 network, that may have additional considerations. Explicit address mapping considerations. Explicit address mapping means that you still allow customers to have incoming connections with IPv4. okay, which is important because maybe your customers will have IPv4 only cameras and they want to still be able to use them from outside their network, okay? So that's very simple example of why this is important. And then, of course, we have the same mechanism that we use today with IPv4 for incoming connections like stun, turn, ICE, etc., etc. So there is basically no difference here when you're using IPv6 only and IPv4 as a service. I didn't mention at the beginning of my presentation, but all this kind of technologies, we call that IPv6 only with IPv4 as a service. It means that, yes, your access network is IPv6 only. Maybe your core network, if you are an ISP, is still dual stack. You don't need that anymore, but maybe typically is that way. But the access network is IPv6 only, and the user in their own network will have still dual stack. And then finally, in the document, I take a look about possible differences, which what is described in the document, when instead of being an ISP, is an enterprise network. So different scenarios. Again, I am not going to go through them, but that's the basic idea. And I think almost my last or final slide is if you are using or you are willing to use this IPv6 only with IPv4 as a service transition mechanism, you need to also to consider an additional document that it was published at the beginning of this year. I think it was March or April this year. I am also the author of this document, which basically say what you need to ask to your CPE providers, okay? So this RFC 8585 is telling the providers, the vendors of the CPEs, please support this transition mechanism and support a way so if the user is changing ISP, it still works. Or if the user gets his CPE broken and the ISP is not selling it, he can go to a shop and buy it and still work, okay? So it's making sure that the people will be happy and the ISP will not get customer support calls to the help desk, which are expensive, because the CPE is all complying with the same set of standards to automatically use one or the other transition mechanism. So summary, NAT64 alone is not a solution. Don't think so anymore, because for sure you will always find applications or services that are inside of your network which only support IPv4, and you maybe are not able to switch those applications or services right now. So you really need to support them still. 464X works in all the cases. The reality is that most of the cellular providers in the world are moving quickly to 464X. Is the only real way to support that. Even if you don't support NAT64, which in general will be my recommendation, it will be good. I didn't mention about this during my presentation, but it will be good if the operating system vendors already do what we call the self-synthesis. So it means that NAT64 is done in the host itself, because that will mean that even with privacy DNS, it still works. So that's a very important point. But this is something that you can only push the operating system vendors, but it's a decision for them. Most of them are starting to do that, so it should not be a problem. And then the document has also two annexes. One of them is an example of deployment of 464X in broadband networks and an implementation of CLAT. So if you are willing to do your own code, you can do your own CLAT implementation. And that's it. Thank you very much.